2 on top. You can't just, it's all ugly.
Well, I have no problem with radicals downstairs.
Seriously?
Yeah, they trained you horribly in grammar school.
Well,
They
also,
should've.
don't you have to pop those?
Is the root 2 part of the natural log?
Yes, it's underneath the. It's underneath.
That's what I was saying.
Well, that's not what I was getting at. Parentheses, absolute values are not. I don't care. What else is wrong? I shouldn't say wrong, but how can we make this look more pretty?
You can factor it.
Oh, got your
you can
math deep room.
expand it because you get the root 2.
What difference does that make?
I don't know.
Well, you can, it's just another constant,
They
right?
can
So
become part of the C.
you
And
can,
that's why it is important.
Yeah.
Because part of the C. Because I think the natural log of a ratio is a difference in 2 logs. The second log is the natural log of root 2. That's just a constant. I think it's the same thing as the natural log of the absolute value. T squared minus 2t plus 3 plus another C. You see my point?
Okay. So if we forget to do that on the test.
Oh, you won't forget now. Just make sure you use all your math D skills to clean it up. That's what I'm asking.
So you just don't give a crap about the arbitrary constants?
Yeah, you know what? I could have been more careful. And sometimes when I got what do you call initial value conditions, I am more careful. I might stipulate to the reader that C sub 1 is just another name for C minus the natural log of root 2. Anyway, those arrows, I think I was just trying to point to that denominator could have gone out there.
Okay.
Yes.
Well, I was about absolute values. I know we need them where we need them, but if we use them when we don't need them, is that bad?
I think so. You want to be efficient. You never want to overstate something. You never want to say things twice.
I'll
Right.
just put an X through my 4.
You what?
Through my 4 on my final answer. I don't know why.
An X through the 4. Oh, 4. I think it said 4, didn't it?
It's the plus. I don't know. I think it's through the plus.
Yeah, Lisa.
I take it back. I didn't see the Bring that out, this should be a 2. I was thinking it was a 2, but I did not, I couldn't read your square root symbol, I think. That must be the reason.
Okay.
I just didn't see it. Brad,
okay.
where you at?
11.3, 39, and 49.
So 11.3, 39, 49. 11.3.
Is these two really kind of,
11.3.
yeah.
You said
It-
39, 49?
Yeah, it was from a while ago, but I just I've been kind of blocked on these ones. Everything else in this chapter is really easy.
Oh, you guys, I like this one.
I figured you would. That's why I'm asking you.
What's that thing with this?
11.3.
You guys, check this question out. This is a good question. I like it. Find all vectors of the form 1ab that are orthogonal to this one. But jeepers, that word orthogonality is screaming at me that I want the dot product to be
You want a scalar projection, right?
equal. Oh no, how
It's a
many?
0.
Equal 0.
You want the dot product to equal 0? Okay.
That forces orthogonality. So in computing, does that give me an 8a minus 2b being equal to, I don't know, is that a 4?
Yeah.
Where you get 4? Oh. Yeah, you're right. Never mind. Now, do we need to solve for A and B?
I don't know. Do you think that answers the question?
No, I don't think that's even the dot product.
Oh, why not? Did I do something wrong?
What did you do there?
Well, I multiplied these two together and threw them over there. Multiplied these two together, threw them over there. And then kept the 4 over here, and then rewrote the equation. Never mind. I did this. First times the first,
Okay.
plus the next times the next, plus the next times the next. I
Don't
just
you need
wrote
it?
it differently.
Oh yeah, you need it.
That same thing.
Okay. Okay.
Just a little math beat.
Yeah.
By the way, does that answer the question?
No.
See, I'm nervous. I'm not sure it's very clear to the reader. So how would you answer? What is the final answer?
Well, you could factor out a 2.
Oh, you
And
know, I didn't even see
simplify
that.
that, yeah.
I did not see that. I do agree with that.
4A is equal to 2 plus B.
Or maybe,
You can set. You can figure out what b equals.
what is B equal?
it'll equal 4a minus 2.
I agree.
Yeah.
So I did my final answer. That vector, replacing b with nothing more than 4a minus 2, gives me this collection of vectors.
Okay, so why do you have a pi in there?
Pi?
What is that next to the element sign?
Oh,
Oh, that's an R? Oh my god.
For all values of a. For all values of a that are an element of the real number system.
Okay,
Better?
okay.
Apologies.
How'd you get that though?
yeah.
How do you get one?
How'd you get 1, comma, a, comma, 4, minus 2?
Oh, I just said, I say to be in the equation. I get 4a minus 2.
I'm sorry, I didn't hear that.
I added b to both sides. Subtracted 2 from both sides.
Okay. And you put b back in the other thing?
And then I replaced b here with this algebraic expression of a.
Okay.
And I think I got a collection of vectors in one parameter. I got a better question. How are all these vectors related to each other? How are they related to each other? Just be a good test question. In words, how are they related to each other? I heard that. They're all in the same plane. Think about it. When I got this vector 4, negative 8, 2, put it in standard position. I think no matter what it looks like, I think all vectors are orthogonal to it, line to the plane. My circle about the initial point. Did you guys see that? By the way, I assume you've not taken Math 32 before. I assume this is new material to you. But if it's not, jeepers, there's an equation of a plane in 2 variables for 3-dimensional space. It is being true.
Say that
I'm
again,
never-
please.
Yes. I'm saying if you had studied Math 32 before, I assume you have not, then I think this is the equation of a plane in 3 space. Somebody have a hand up. I missed you. I'm sorry.
I had another question from the book. 11.3.65.
11.365.
I still wanted to see 49 too, if you could do that.
Oh, can I do it? I don't think I can. I get so lucky in this classroom. Somebody yet again left the computer on, logged in. What's that?
Are you still trading?
Actually, I have no idea how to get out of it. Document camera. Well, I'll stall. When this comes on, maybe you guys can tell me what to do, because I really don't know what to do. Bradley, what'd you have?
49, same section. So, I guess this is my problem, because I'm looking at orthogonal projections and finding orthogonal vectors. And so you just find orthogonal vectors by setting the dot product equal to 0, right? And so orthogonal projections, what exactly is the difference between an orthogonal vector and an orthogonal projection?
So I think, if here's one vector, call it v bar. Here's another vector u bar. What is this thing right here? Anybody?
Just the dot product.
Oh, no, wait, no, you guys are fine. You're telling me how to compute it. I didn't mean that. I just meant visually, geometrically, what is it?
Well, we would treat B like it's a, well, we find the unit vector B, and then we project, what U, if we broke into components, onto B.
So you're saying perpendicularly come down this way.
Yep.
Now, does this vector up here, does it go in this direction or that direction?
Neither.
Neither. I think with my blue pen, it's really this vector right here. It's a vector in the same direction as u bar, but whose magnitude was a scalar projection of u bar onto v bar. In notation, this represents a blue vector, and the author just wants to go through generating that.
Okay.
Whereas I think in black, this thing right here, now that's going to be a vector in blue or in red. Neither. It's just a scalar. It's just a number. What number does it represent? It's the magnitude of the blue one, right? It's the magnitude of the projection of u bar onto v bar. There's a difference. And I probably would have been more careful. I would have probably said the scalar projection of u bar onto v bar is that number, which is the magnitude of the projection vector of u bar onto v bar.
Okay.
There is a difference. Now, the reason we have this question that you're asking about number 49.
Yeah. That's more or less what I was unsure of.
It's
for
this
that one.
important.
Yeah.
It's this important. If I have two vectors here, and let's restrict our attention to two space. Do you guys agree? Sorry, I'm standing right in front of it. Do you guys agree that these two vectors span all of two space? I'm not trying to trick you. Would you agree that any vector in two-dimensional space in the plane that contains those two vectors can be expressed as a linear combination of those two? Okay, if you're saying yes, I agree with that. But a lot of times in practice, particularly some physics applications later on, it becomes quite cumbersome to talk about all those other vectors in two space that can be expressed as a linear combination of these two because there's work to find the components to scale the number in the front. And so a lot of times what we do instead is we'll keep v bar fixed. And we'll go ahead and look at this vector here in blue, slide it over, and let me call it w bar. I think v bar and w bar span the same darn space, but they're orthogonal. I force orthogonality with my spanning set, my generating set for this space.
Okay.
And when I'm saying this to you guys in front of class, I know you're receiving this through your ears by saying, oh, he's in two-dimensional space. But when I'm saying it, I'm thinking even some bizarre, more abstract vector space where they don't have to represent vectors like in two space or three space or even in space. They could be something completely different, like matrices, functions, could be a variety of things. And so we do have a habit, a lot of times in applications, to force orthogonality for a spanning set of whatever they are, vectors, functions, whatever the case may be.
Okay.
That was just a glimpse at it. I promise I'll be much more detailed next semester. Well, Brad, you're taking 33 right now.
Yes.
I missed this semester.
Okay.
Different class.
And so parallel vector, that's just, you just take the vector and then divide it by its magnitude?
This one's parallel to that one.
Yeah, but they're asking for P, which is parallel to V. And so P is unknown, so we have to find that. So if you just take V and you divide it by its magnitude, you've got
That's
a parallel
fine.
vector.
Can I use a different color?
Okay.
How about this one right here in green?
Yeah.
Here's another vector that's parallel to V bar.
Okay.
Vector in green. It works just as well.
So you could just use V bar?
I'll be honest with you, it doesn't matter in terms of spanning, but I take my words back a little bit. If you want the spanning vectors to be unit vectors, then
Okay.
you divide out by V bar's magnitude. If you want them to be unit vectors.
It doesn't really say
It
here
doesn't,
to.
right. But if you did want to be unit vectors, then you divide out.
So
by V
you
bar.
could potentially get two different answers, or
Yes.
multiple answers for this? Okay.
We're gonna use a 65.
Oh, sorry, I've already forgotten. You said what?
Number 65 on 130.
Can somebody help me? I'm serious. Can you tell me what it's coming from?
So it's the hexagonal sphere packing.
No, I meant I got a problem with the computer.
Oh.
I've got it on document camera, but it's showing this. Does anybody know
The
why?
camera's probably frozen. Like you can freeze the image.
Oh, how do I freeze it?
Look for a ice.
Hit the freeze button, sorry. Never mind. Thank you very much, Alex. I appreciate it. Okay, you guys don't look yet.
We're looking.
And just answer yes or no. Is that better?
Yes.
Okay. Imagine 3 unit spheres, radius equal to 1, with centers located there, there, and there. Now place another unit sphere like I have in red, symmetrically on top of these spheres, with a center located at R. Can you find the coordinates of R? Bless you.
Well, the XY plane components are gonna be at the center of the XY components out of the other 3 vectors, the other 3 centers, P, L, and Q. And then whatever that distance is from, say, like P to R's XY coordinate is also gonna be the distance from,
P to...
the distance from P to R, from O to R, from Q to R is gonna be equal to 2 times the unit radius.
All right, I'll buy that. I think because these spheres are touching each other tangentially at the point of contact, I do think the distance from P to R is just going to be twice the radius of one of the spheres. I think they told me it was 1. Yeah, they're unit spheres, so consider the radii 1. And so I think that distance is just going to be 1 unit. And now you can just draw yourself a lot of symmetry. I think you can clearly identify its location just by looking at some right triangles, putting in the appropriate angles. And I think that'll answer your question directly. Did you really?
They did that's both the equations to they set them equal to each other and that equal to R. And that really confused me.
They said what equations equal to each other?
All this, the equations of all the spheres.
They said them equal to each other.
Not really a contact.
R isn't a unit sphere, right? Or is it?
It is.
Yeah, they're assuming it's a unit sphere. They want all these spheres to be the same. By the way, this is an interesting question, isn't it? It's sort of like the best way I can pack a collection of spheres. I mean, that's really what's going on.
Could you cross OP and OQ to get at least the direction that the arrow would be pointing?
Yeah, I was thinking to get the Z height. I mean, it's just like a...
Unfortunately not.
I was thinking to get the Z height. The Z is just like an equilateral triangle and get that. It would be 60 degrees.
Yeah.
And then it's just like the cosine of 60 degrees to get that. But I...
Well, let's go back to what somebody else said. Maybe I'll do this. If I look at this vector and this one, that cross product is going to pass through the center of the sphere R. By the way, you guys, I misspoke. R is the center. My apologies. I thought R is the name of the sphere. R is that point of the center. Oh, I don't know. I'll just answer my question anyways. What do you think?
I don't think it will.
Perhaps.
Are you sure?
It has to, because those 3 make a plane.
See, I think we're wrong. For that very reason. I think since O, P, Q, which I think are the centers of spheres, are in the X, Y coordinate plane, I think if I look at the cross product of two green vectors, I will be orthogonal to both of them. I think I'm going to miss that center. Because I think that center is located somewhere hovering above this triangle in the XY coordinate plane on its interior.
So find the center of the triangle and then,
Well, that'll work. I'm just shaking you up because somebody said this. I think the cross product of the 2 green beasts will not pass through the center of the circle. The center of the sphere, which is a point R. Do you guys agree? Okay. And I was just suggesting it's probably going to be much better off if instead of solving a bunch of equations, I can't imagine why, that maybe instead just look at all the symmetry. I mean, certainly this center, this point R, is going to lie above. It's going to lie
center
above
of
the.
the center of
Be more careful in my picture. It's going to lie above the.
the XY plane.
True. Also directly above the.
X-axis.
The x-axis. The x-axis.
Yeah.
Yeah. So that's what I'm saying. You know, you could do this. Draw a nifty little right triangle. Now I know you can't see by right angle because everything's at is viewed at an angle, but this is my right angle.
And so that's just going along the x-axis?
Yes, my apologies. This leg is going just on the x-axis.
Okay.
I agree.
The hypotenuse is gonna be equal to 2, right? Because it's 2 unit circles of radius 1.
Yeah.
Oh yeah, because you're connecting centers.
Yeah. So then the adjacent side of that angle, is that also 1?
Yeah, because
Must be, yeah, it
it's
has
the
to be
radius above.
No.
Okay.
No, that's
No, it goes
see
to
the not the
60.
center.
Oh, no, it's a little more than the radius above, you're right.
Oh.
We only know one side.
It's slightly more than.
You can make that an equilateral triangle and just find the center.
Yeah,
Would it be equilateral?
yeah, it is.
I'm serious, I'm stalling, I don't know.
It is definitely equilateral, yes, because of the symmetry of.
Wait, which one's equilateral?
The
Connecting.
one on the XY.
My apologies, I thought you were talking about my green one. So you're saying this red one is definitely equilateral?
Yeah.
Yeah.
Well, I'm thinking also that the green triangle would be, would be isosceles. Is that the word? Yes. With.
Sorry for shaking that.
With the hypotenuse of 2 units, and then the vertical y component and the horizontal x component, the z component there and the x component would both be equal to each other.
But isn't the x component of that green triangle there just root 3 over 2?
Yeah.
Shouldn't it be just halfway?
I think so.
So then from there, we can just use Pythagorean theorem, and then we have our answer.
I agree. You know something else interesting about this, you guys? Watch. With my blue pen, I didn't see this, but with my blue pen,
Do you have a pyramid?
that triangle's also,
Another isosceles.
yeah, isosceles. Yeah. I said isosceles, I meant equilateral.
Is that an equilateral
Equilateral. I didn't get the last word.
pyramid? I don't.
Maybe you could make a.
Well, the whole thing is.
Could make a pyramid, yeah.
Anyway, I would have gone that approach, take a look at some of those. Guys, can I stall this for a minute? I'm not trying to avoid the question. I'm just kind of nervous. Because I want to finish up my last discussion. I want to talk about the exam, and if we need to, we can come back to this. But that's what I would look at, instead of, I'm not sure what the office is trying to do in solving equations.
Yeah, because I did that, just in like saying to, like,
I think the picture's kind of hard to visualize, because you see the portion of the big graded one that you can't see? That's actually lying also above the x-axis.
So this point
Yes.
here.
The only reason I was asking about
This
R,
here is going to be.
because you said it was a unit circle, so you're
So this is, yeah, this is
assuming.
the x, y.
I think he said the ones.
Here's another unit sphere. This one's above, right?
Yeah, now place another
You
unit
know,
sphere.
this x
Oh, I
component
see.
right here is going to be.
But if it wasn't, potentially, we couldn't necessarily assume that this was an R to any of the other.
Yeah, you're right,
questions.
and that would be more difficult, wouldn't it?
Okay.
But I think when it comes to applications, the whole idea of packing, we want them all to be the same
Here, there,
size.
so
I wish I could say something about this. I saw something in a store, there's new packaging of something, and I thought, it was so illogical, it didn't utilize this. Oh, something else. Darn it. This weekend when I was online reading news, some science news, I came across an article where there are some researchers who are looking at some data from radar signals to the Big Bang. They're yet again going back and saying, as we get out further and further away deep into the universe, parallel lines seem to be separating. And now they're saying, indeed, it seems to be mathematically modeled by that thing I called a hyperbolic paraboloid. Which I think would be just so interesting in terms of geometry. Sorry, I'll come back.
Why that over any other
So-
surface?
Just because of the way they're receiving the data that was echoing from the Big Bang explosion. It's coming back in a way that we can mathematically determine what the trajectory of the sound waves were.
What,
I'm listening.
I mean, just, why that surface specifically? I mean, what would have caused it over any other, possible?
Yeah, I would expect that a naturally occurring object like the universe would take the simplest geometry available to it, right? Something like that.
That's not simple.
No, it's not simple.
That's just a saddle.
But wouldn't it be simpler just to have an expanding sphere of in
Just
three
beautiful.
space?
Look, if you took a cross-sectional slice like this, wouldn't you just get a hyperbola? Or take a cross-sectional slice like this, you get just a parabola. It's basic common section.
What
It's
you're
very
saying
natural.
is, where else in nature do we get a nice hyperbola?
Yeah, I mean, I
call it
I could see in pretty much any other explosion that not taking place on the surface of Earth, you would get a spherical.
No, wait. I didn't say the explosion itself is behaving like this. I just meant the material they're finding is moving through space that seems to be shaped like this. It doesn't necessarily have anything to do with explosion.
Oh,
We're just talking about the shape of the universe.
Don't they think that that's how gravity wells are sort of shaped too? Like things take.
Well, around an object, yeah, I agree.
Well, and I've heard before that physicists speculate that the Big Bang wasn't exactly uniform, and that's why the cosmic background radiation has all these sort of hot spots.
Yes. Yeah, I've heard the same thing.
Yes.
I've read the same thing. It's interesting stuff. Anyways, you guys, I gotta come back. Last time you and I met, we made a decision. Well, I shouldn't say decision. We discovered that if I have an object run the upward direction, and gravity is the only acceleration actually acting on this object, do you know what I find? That if the initial velocity vector were equal to, I don't know, you guys, I'm making up these symbols out of thin air. How about u sub naught comma v sub naught? And if my initial position vector was equal to, x naught, y naught. You guys, you can call it whatever you like. Then we found out that the velocity after time t, that is a v by the way, the velocity after time t is a vector, can be described as nothing more than, do you guys remember what we came up with? U sub naught, were you here? T plus the initial horizontal portion of the position. And in case you were here and you were listening to me, I guess the other component would be, actually,
That should be the position.
that is the position.
Yeah.
I got an idea. That's an R. Oh, be quiet. And I think the vertical component is going to be negative 1/2 g t squared plus v sub naught t. I feel so alone. Plus, why not get rid of that?
That's
But I can,
like,
yes.
all that is the gravity function. We just went over this in physics, like.
I know, but did you get my derivation? I can do it again if you like.
No, there's no need. This is so straightforward.
But
Sorry, I was.
But in class, I did drive it though. I did
You did?
drive it out of thin air. I hope I did.
No, I don't remember.
Do we have to remember how to derive this, or just how to use it? We need to know how to derive it?
Because the velocity function there should be just a constant with gravity being on the.
Yeah, and you know what? I should have put that in. Actually, the initial velocity in times t. What does that end up being?
The initial velocity ends up being 0 if you're assuming that it's getting taken by gravity.
Well, no. Here's the initial velocity. What's the velocity at the time t as a vector?
Oh, okay. Yeah, let me just.
Comma. Say it again.
Negative gt.
Yeah, I think it'd be negative gt.
Plus the
Yeah, plus the initial vertical component of the initial vector describing velocity. Do you guys agree? It's just that sometimes I want to do this. What if I had the x-axis here, and I threw a projectile at an angle? Well, initially at an angle. Let's call it alpha. And suppose the initial velocity had magnitude of v sub naught. Would you guys not agree that I can think of the horizontal and vertical components in the following fashion? Wouldn't the horizontal component clearly be the magnitude of the initial vector times the cosine of alpha, and the vertical component is? And here's the magnitude of the initial vector. It's the magnitude because it's simply the length along the diagonal. Are you guys okay with this? Because I can talk trigonometry if you need me to. Be honest. You're paying money to be here. It's just that I think what that really means is that my velocity vector is simply going to have, in terms of other components, the following. Look, with my initial velocity vector, is it going to be this? Isn't that my initial velocity vector?
You mean sine? Are you starting to say sine alpha or legitimately of 0?
No, I mean alpha. Don't listen to me. Your alpha sign.
Sorry, you threw
I'll
me
pay
off for a
attention.
second.
I made a the angle out of thin air. I didn't remember. But you guys, guys, that means over here with my velocity function, I'm simply gonna replace u sub naught and v sub naught with these components. I think my velocity after time t is simply described by this component. The magnitude of the initial velocity vector times the cosine of, okay, this time theta, alpha, I'm backwards, comma negative gt, plus, well, the vertical component of that initial vector for velocity, I think that would be its magnitude, times the sine of my angle, I'll be careful and call it alpha.
You know, this looks so pretty, but it only really works in 2D motion, right?
Well, just give me another 2 minutes, I'll get out of 2D. I'll show you.
Okay, yeah, I was gonna say, how do you account for it with like, because you run out of crap, you know, you can't go like cosine, sine, what do you go after there? That's, I don't know.
You know, it depends how you orient your space. Depends on what axis you refer to as what, but I'll draw a picture and I'll do them in a few minutes.
Okay.
You guys, I just want to make some changes, because last time I was in class, I was so darn limited. We were throwing something straight up, just dealing with gravity. What about throwing it at an angle? There's a difference. So I think my position vector function, the vector value function describing the position of a particle thrown initially in that direction alpha, which is, by the way, is going to go like this. I think the position function is going to be the antiderivative of this garbage. But that's, yeah.
You just answered it.
Okay, let's just generate. By the way, suppose I'm just throwing a projectile from ground level. Where did I get this? Plus the initial horizontal displacement, which is 0, comma negative 1/2 g t squared, plus my v sub naught's magnitude times the sine of my, am I calling it alpha? I hope so. Times my t plus my y sub naught, but I'm just going to assume that's 0. Yes.
What if alpha's changing?
Oh.
But I think alpha is simply the angle initially through a projectile in.
Well, yeah, but let's say theoretically it was changing. How would you do it?
But how could that angle affect it? If, okay, the angle can change all you want, but after the projectile's been released, it's not in contact with whatever it was launching, with whatever was launching it. So.
Eric, I agree with what he's saying, but are you suggesting that we should leave alpha as a parameter?
Yes.
Okay, that's different. That's different. Do you know what? I'm safe because that's it.
Okay.
No matter what alpha is, you can treat it as a parameter. But I think that would be my position vector. And if I were to do this, let's see if we can answer this question. How far does the projectile run? How far does it go?
All you're gonna do is use the velocity function, set it equal to 0, find that distance, and then.
I can't because it's a vector. I can't set it equal to 0. It has no meaning.
Ooh, true enough.
You have to find the 2 times. You have to find the 2 times.
Or I'm not going to say the y-hat portion of velocity vector. Is the answer?
I had an ear infection a while ago. I can't concentrate at all. I can't even focus. So can you say it one more time with
So
one
you
of
have
my voice?
to find where the where T is, like where it stops.
Can you start over again?
You have to find where T the y component equals 0.
Perfectly put. He's saying, to find out how far this projectile goes horizontally, we're not going to answer the question yet, but let's first find out how much time it takes this object to hit the ground. And so let me go ahead and take this vertical component and set it equal to 0. And if I do, I think that vertical component, this y of t, if I can think of it this way, sorry, interpreting this vector value function as having these 2 components. 2 functions in time t. Let's set yt equal to 0. I think that necessarily implies that negative 1/2 gt squared plus the magnitude of v naught times the sine of alpha times t is equal to 0. But doesn't that just simply suggest that t is equal to, I have no idea. You guys, by the way, just formulas in the book, I never remember them. I just rederive them. But if I were to solve for t, I do think I would get 2 times the magnitude of v sub naught times the sine of alpha over g. Or is my math D okay? It's just math D. Is it okay? All right, if it is okay, can I open up your book? Because I think if you guys are going to carefully look at what the author of this text says.
All you did was add it up.
Oh, yeah, I see, never mind.
he does have a list. Okay, you guys can't see it yet, but it's coming up. He does agree with me. Before it comes up, he's got a name for this. He calls this flight time. It's how much time I'm going to be in the air. And I still haven't answered my question. I want to know how far this particle moves. And I think to answer it, so there's this flight time, same as mine. But I think to answer my question, to find out how far this object travels, I think we should do this. I think we should come up with my horizontal position and evaluate it at that time t. So if I take this horizontal position function and evaluate it 2 times the magnitude of v naught times the sine of alpha all over g, I'm going to get the following. The output is just its magnitude times the cosine of alpha. And so I get its magnitude times the cosine of alpha. Do you guys agree with my algebra? Would you guys not agree that another name for 2 sine alpha cosine alpha is? Oh, by the way, this represents the horizontal position of my object, which means I can ask this question. What must this angle alpha be so that I maximize the horizontal range for which I'm trying to reach with this projectile? I think the answer is easy to answer.
45 degrees.
Where'd you get that?
Doesn't everybody know that?
But why?
Oh, because those 1:1 ratio.
What was that?
Because
It's common sense, it's the optimum angle there between.
Well, I think this is the reason. I know what you're saying is true, but here's why it's true. Look at this big mess over here. It's just a number. But it involves the sine of some angle. And I think the sine of some angle is going to be a number between -1 and 1. And the biggest value could be is 1. But it's going to be 1 when this whole angle right here is 90 degrees. But that's going to be 90 degrees when alpha itself is 45. So I'm just justifying it. That's all I'm suggesting. And by the way, he gives us a name, I think, doesn't he? Oh, he's got the same thing I do. He calls us a range. By the way, I don't like this list at all. I think it's all wrong. If you allow me to just stand initially off the ground. And I think none of this works. And I'd like to be able to answer these questions by not memorizing these. Because if I lift off the ground, these will not give me the answer. So can I phrase a question we can run through it? Without necessarily using these formulas. Catherine?
Have you anything from V to get a position function?
Yes.
What happened to your function?
What happened to my...
To your constant of anything